Question number 6, it says balls thrown upward and forward, and it follows h equals 20t minus 5t squared. And as it descends, it hits a point on the wall 50 meters high. So I've kind of shown this here where it's going to fly through here and then hit the wall 50 meters high. So find the downward velocity and acceleration at the moment of impact against the wall. So first of all, we need to solve this quadratic equation for height. So we want to know the time when the height is 15 meters. So 20t minus 5t squared. So solving this quadratic equation, so I'm going to factor the negative 5 out. I get t squared plus, sorry, that's going to be minus 4t. And then since it's negative 15 on this side, it's going to be, we factor out the negative 5 from the negative 15, and we get plus 3. To solve this equation then, we just factor this, t minus 3, t minus 1. So that time equals 3 seconds, and that's going to be 3 seconds here. And time equals 1 second, so there's an equivalent point somewhere over here at 1 second where the ball is going to be on its way up. So the time at which it hits the wall is going to be 3 seconds. So I'm going to just make sure I highlight that. And then we want to know the velocity and acceleration at that time. So now at this point, we're going to find the velocity function. We're going to find h prime, which is our velocity function. And differentiating this, we get 20 minus 10t. And we want to then find the velocity at 3 seconds. So this works out to be 20 minus 3 times 10, and the velocity is going to be negative 10 meters per second. The second part of this wants us to know the acceleration. So to do that, we need to differentiate one more time to get the second derivative of velocity, or sorry, of the height. So v prime t is going to be our acceleration. So acceleration is going to be negative 10. So in this case, acceleration is constant at negative 10 meters per second squared. And this would represent the constant acceleration of gravity, which is a rounded version of 9.8 meters per second squared.